up and running here. So this video is going to be worksheet number 3. And for folks who don't have the worksheet, I understand folks tune in once in a while who aren't in this class. Maybe take a screenshot of that. And then you can decide, how you want to work with this video, what problems you want to concentrate on. But I'm going to try to explain each and every problem in a detailed fashion, at least to the best of my ability. I guess you can see that. But I'm going to start with problem number 2 on the worksheet because I think it's a better example of what we need to look at. And then we'll do problem number 1, hopefully a little easier. Let me move my science cart. Oh, my trusty science cart. There we go. Now I won't have to move the computer. All right, so this is the number 27 raised to this exponent. And there are 3 parts to this exponent. The minus sign means reciprocate. Remember, the math is a language. Reciprocate. There we go. Wake up, Jim. That, which simply means that A over B becomes B over A. Right? And every number can be thought of as being divided by 1. So eventually we're going to do a flip. And all of these operations are independent, as in you can do them in any order. Well, that's the right term to use, but I think everybody knows at this stage what 27 squared means. I need not talk about that. This is the operation that poses problems for first and second year algebra students. So let's talk about it. These are roots. That is a cube root. A cube root is actually the length of the side of the cube. And volume equals length times width times height. And those numbers can be different, but a cube root, they can't be different. If that's the length, then that's also the width, and that's also the height. And we're trying to find which number gets us a product of 27. Obviously, we're not looking at very big numbers here. So learning the language, hopefully you understand that that is a 3. Because 3 times 3 times 3 is 27. All right, so what goes inside a cube root symbol? The actual volume. And we're looking for the side length. And that's what that is about. Now, I think it's easier to find the cube root of 27, which is 3. And it could have been expressed as the cube root of 27 may be written as, an equal sign means may be written as, can you see? Yes, you can still see that, as 27 to the 1/3. Those are identical calculations. And computers work really well with numbers. Radical signs, we're starting to see computers deal with that as well. But perhaps that's why this was originally written that way. All right, so the cube root of 27 is 3. 27 squared, I don't know off the top of my head. And flipping 27 gives us 1 over 27. Which of these would you like to do first? I would think you would do the cube root of 27. All right, so let's erase that. And let's write the problem, and then the order in what we do things is our choice. So 27 to the minus 2/3, I would like to write as 3 to the negative 2. That's another name for this because I took the cube root of 27. I'm going to do 3 squared first, so that's 9. 3 squared is 9, but I still have minus 1, right? Minus 2 is the same thing as minus 1 times 2. Okay, so I'm going to do 3 squared, which is 9, and then 9 to the negative 1 is 1/9. And we talked about that with the situation m times m times m, 3 of them. Here we have 4 of them, right? 3 of them go into 3 of them, 1 time, leaving M there. And the rule for that is M to the, you're counting. So M to the 3 minus 4 is M to the minus 1. And that's M over 1. M to the minus 1 is 1 over M. And that sure looks like I took this fraction and reciprocated it. So that's how you do that problem. Okay, so now we're going to do number 1, which is 16 to the 1/4. And while I erase, you think. 16 to the 1/4. So I will start up as soon as I've done the erasing here. So I got to get a different eraser because these claws don't get the job done. I think I put one in my pocket. There it is. That's better. So I'll speed that up. All right, you've had times to think. 4th root. I have a hard time drawing a 4-dimensional picture. And I'm looking for one of the sides. That's really what that's about. So all I can do is say, I know something times something times something gets me 16. You know, I think that's a 2. I can't draw anything, right? A square, I can tell you something times something, right? And so a square is a 2-dimensional picture. And I'm looking for one of the sides when I write 9 to the 1/2. Right, well, one of the sides of this 2-dimensional picture means that's a 3. But instead of writing it as a 3, I think this time I'll write it as the square root of 9. So that length is a square root. Square root of 9. What's the square root of 9 times the square root of 9? 9. I guess that means that if I had 10, then I'm looking at the square root of 10. And the square root of 10 times the square root of 10 by definition must give me 10. And I think the square root of 10 is a little bigger than 3. I'd have to go to a computer or a calculator to find some decimal accuracy because I don't know the square root of 10. All right, so this was the 4th root of 16, which is 2. Okay, we're now on problem number 3, where we're going to practice these things a little bit. Let me see what problem number 3 is. I need my glasses. Log 8 base 16. We're on the same topic. Slightly harder problem because we said in class the first 3 days that logarithms are trying to find the value of the exponent. So I'm trying to find the exponent that takes me from an 8 to a 16. Did you know 8's a perfect cube? Yeah, and I think the cube root of 8 is 2. And I think 16 is 2 to the 4th. I think conceptually my answer is 4/3. Okay, but how do you find it? I've done these for a long time. You need the reps. Well, first thing we have to rephrase the equation. All right, and the inverse of this is putting it in an exponential form. So 8, but I'll call the exponent x. Arabic for the letter stands for the word something. 8 to the something gets me 16. Okay, well, immediately, I'm not sure. Oh, well, let me think about this a bit. Let's look at a squared times b cubed. Can I simplify that? No, because they're not the same base. Can I simplify b squared times b cubed? Yeah, b squared is b times b cubed, which is b times b times b, and I can see that, oh, I can count that number of factors, it's 5. That's what exponents are in this case. Okay. Well, I can't do that here right now because 16 isn't base 8. But do base 8 and base 16 have something in common? Yes, the number 2. 8 is 2 cubed to the x. So let's look at that situation. Let's look at b squared cubed. Well, that means I'm doing b squared times b squared times b squared. And I know horizontally I'm adding them up. That's b to the 6. So what's another name? Well, we know 16 from the previous problem is 2 to the 4th. So what's another way of saying this calculation? Can I write it more simply? Yes. 2 to the 3 times x. That's 1, 2, 3 strokes of the pen versus 1, 2, 3, 4, 5. That's how I define, is it simpler? Can I write it more quickly? 2 to the 4. Well, you know, I think if this is true, that 2 to the something has to equal 2 to the 4. Well, I got a feeling that that 3x has to equal 4. So if 3x equals 4, what was our exponent? 4/3. Oh yeah, I'm supposed to take the cube root of 8, which is 2, and then I'm supposed to do 2 times 2 times 2 times 2, as in 4 times, which gets me 16. That's problem number 3. I'll write problem number 4 now. Oh, I'm in a roll here. And then while I erase, you try problem number 4. 100 to the 1/2. That's a two-dimensional picture. That is the area. And I think I'm looking at one of the sides. Yes, this is the same thing as the square root of 100. And the square root of 100 is 10. And I think it's easier to write 10, 2 strokes of the pen versus 1, 2, 3, 4. I'm going to express it that way. Okay. And this is, I think, the 4th day that you're kind of looking at this. And I said rule of 4, a few minutes a day on each problem, and usually about 4 days later, start to make some sense. So now we'll just throw 100 problems your way as quickly as we can. We'll spend 4 days on it. Now, what number am I on? I'm on number 5. Okay, I erased, broke my pattern. 81 to the 1/9. Okay, and I hope that you know what log is asking. That's a command. It's asking you to perform a mathematical operation, and it's asking you to find what? The exponent. On top of 81, that gets you 1/9. All right, so let's go. 81 to the x equals 1/9. Again, not the same basis, but 81 could have been expressed as 9 squared to the x equals 1/9, which is 9 to the -1, right? We can reciprocate, right? 9 to the -1 means to flip 9 over 1, which gets us 1/9, so we'll express it that way. I don't need to write that, so I'll ignore that. And it looks like 2x has to equal -1, therefore x equals -1/2, which tells me I'm supposed to reciprocate this and take a square root. If I take the square root of 81, it's 9, and 9 over 1 reciprocated is what we were looking for that produces that quantity. So logarithms take us from the quantity to the exponential activity. That's a little harder than going from exponent to quantity. Why? Because you've had more reps in your life of going from exponents to quantity. You've been doing that. I wish at the same time that you had learned that you'd also been doing this. All right, because that's the inverse operation. Oh, I erased after I put the next problem up. So now we're doing log base 8 of 1/64. Log base 8 of 1/64. And we want to know what exponent that is. What exponent do you put on top of 8 to get 1/64? Well, 8 to the x equals 1/8 squared. It sure looks like I'm doing the squaring in the denominator. Oh, that minus sign means I'm doing the squaring in the denominator. Okay, got to speed up here a little bit. Oh, I erased this one. I go to problem number 5. That was problem 5. That was problem 6. Oh, I'm in trouble here. That was problem 6. Okay, log base 8 of 1/64. Log base 8 of 1/64. My apologies, throwing you off here for folks who don't have the worksheet. All right, so now I'm going to go to 7. I'm going to write 7. Equation of the line. The equation of the line that passes through the points -1230 negative 1230, and 511. Okay, you try that. I'll get rid of this. Step one, for those of you who are just learning how to do that, I think you should put these numbers in tabular form. Okay, and the easiest way to do this is to get rid of the first number, put a negative 12 in, and 0 times anything is 0, and we want to get a 30, we write 30. I have now made a correlation between those. Now, when I put the number 5 in, I get 17. I don't want 17 because 17 plus 30 doesn't take me to 11, so I get rid of it. When I put negative 12 in, I get 0. Well, 17 goes into 0 nicely, and 17 goes into 17 nicely. It also goes into 34 nicely. It also goes into 51 nicely. I would like to make table values that make that happen. I can see 5 plus 12 gets me 17, and 17 goes into 17 nicely. Now, I think I explained this, and I'll do it again. Repetition is your friend. Let's look at the 3 ways that I can perform this calculation. There are 3 ways that I can do this. All right, this is on another video, but doesn't necessarily mean people are looking at the videos. In fact, I know some people aren't, because I can tell on Canvas if you've watched it or not. 4 times 6, 24, divided by 2 is 12. That's one way you could do it, and that's the way that most students are doing it. You could have done 4 divided by 2, which is 2 times 6, which is 12, and a lot of students are doing that. But the one that's most important is to be able to see that you could put 2 into 6 and get 3 times 4. And if you want to understand conversion, as we start changing these numbers to squares and cubes, then you definitely want to see that. Because that will unlock your ability to see the conversions of many functions. So I put a 5 in, 17's cancel. How do I get from 30 to 11? I go down 19. And doing that, how do I get from here to there is a whole lot easier than y2 minus y1. y2 minus 1, I have to do 11 minus 30, which is also minus 19. Nothing wrong with it, but if you ask yourself, how do you get from here to there? It's a simpler calculation. All right, that was problem number 7. Okay, I'm going to erase that. And I'm going to put an 8 here. I'm being very careful now, mindful. And I'm going to look for 4 points on the line. Y equals fine. 4 points for the folks who aren't in the class and don't have the worksheet. That could be Pasang and Dreama and Pema and Chana. Say hi to Joy and Colonel Singh for us too, but we miss you. Try to get over there and see you again. Hopefully soon. Where was I? 4 points on the line. 4/5 times x plus 3 minus 17. Ooh, I must have had 17 in my head. Freudian stuff going on here. All right, so 4 points. I think it has something to do with this. And I hope you're saying 5 goes into 0, 5, 10, and 15. Oh, those are going to be 4 friendly numbers. What makes a 0? -3. What makes a 5? 2. What makes a 10? 7. What makes math? Patterns. 12, 17, 22, so on and so forth. Those should be friendly numbers. What happens when I put a -3 in? I get 0. 0 times any multiplier is 0. Looks like my y value is minus 17. What happens when I put a 2 in? this cancel, and I get 4 minus 17, which is minus 13. My God, that just went, oh, up 4. Yes, remember, I'm on a number line. And negative 13 is to the right of negative 17, so I'm going up the number line. Oh, this could get silly. So let's go up 4 again. Let's go to negative 9. Let's go to negative 5. Let's go to negative 1. And let's get into the positive terrain. Let's get a 3. And let's see if this really works. Remember, I'm trying to explain everything in greater detail. X plus 3. Let's find out if I put a 22 in here. Oh, I know what 22 plus 3 is. It's 25. And that tells me I'm going to jump 4 times. The number 4, I'm going to jump 5 of those. There's 1. There's 2. There's 3. There's 4. Oh, there's 5. 5 jumps of 4. 20 minus 17, 3. Got to try to make this stuff easy. So that was number 8. Oh, got to do number 9 here. And you think about it while I erase that. Number 9. Now write number 8 in mx plus b form. 4/5 x plus 3 minus 17. We want to write it as mx plus b. All right, while I erase, you think about that. Okay, that means, do you have your elementary school mathematics in your pocket? Because there's no thinking here, it's pure mechanics. Do you know that 4 times x is 4x divided by 5? Did you know that 4 times 3 is plus 12 divided by 5? And did you know that you have to subtract fractions, and these are both fractions, right? Provided they have the same denominator. So let's erase that. And let's take our 4/5 x. I'll move the x back there, but they are the same thing. Plus 12/5. I'm going to take 5 times 17, and I'm going to get 85. And how did I do that? I did 5 times 17. I did 5 times 10, and 5 times 7. 50 and 35. Okay, don't need to put it on paper. Just learn to do that. And I am subtracting 85/5, which is the same as that number. So my final answer is the negative is bigger than the positive. So I'm going to do in my head 85 minus 12. And I know that's going to be a negative number. So 4/5 x. Take 10 away from 85, 75. Take 2 more. And I'm getting 73/5. And it's negative. Those are the same lines. And I think this form is only going to help us graph higher degree polynomials. That's a better form. All right, all you need is a point, a slope, -3, -17, over 5 up 4, and you're graphing that. Oops, I did it again. Erase the original problem, move to number 10. I'll write that problem, and then you think about sketch. Oh, okay. So we're actually sketching 4/5 x plus 3 minus 17. Well, you want to get good at seeing the point that is being displayed, which is -3. I'll call, now I got to go down 17. Let's call that -3. And then let's estimate down here. Let's say that's -3, 17. And horizontal change in x, 5 units. Up 4, that's a little smaller, taking me to a new location. If I add 5 to -3, I'm at 2. If I add 4, oops, I forgot the minus sign. If I add 4 to -c, I'm at -13. We kind of just did that problem, putting arrows on both sides. Domain is all reals. There's not a number that I can't add 3 to and multiply and subtract. All numbers work. Everything works here, everything. So the domain is all reals and looks like I'm heading to positive infinity. And if I look to the left, negative infinity. So the range, the y values in the table, all reals. I want to start talking domain and range so that you get familiar with the terms. Oops, I did it again. We're on number 11. Number 11, sketch, another sketch. This time it's y minus 2 equals, come on, Jimbo, where are you? Minus 2/3 x plus 4. Minus 2/3 parentheses x plus 4. Sketch. Now, one thing you want to learn in math is that if you're struggling to see something, and I'm not sure you are with this problem, but if you are, can you write it differently? Yes. Y equals negative 2/3 x plus 4 plus 2. Can I really do that? Can I write subtraction as addition on the other side? Let's look. 5 minus 3 is 2. Is that the same as 2 plus 3? You tell me. I think I can do that. I did it. Can you see some points here and then sketch them? Can you look at that and say, oh, let's make this negative 4. That gets rid of the multiplication. Gets me a 2. I hope you can see that. If you can, then you go right to negative 4 up to, we'll call that negative 4, 2. I'm going down, so I don't want to put that there. Negative 4, comma 2. All right, that's that point. We just need one more point. Now we made a 0, right? Negative 4 made it 0. Now we want to make it 3, and then we want to make it 6, because 3 goes into 0, 3 goes into 6. Let's make it 3. I think that's negative 1. And if I put a negative 1 in, the 3's cancel, and minus 2 plus 2 is 0. Well, that's nice. That's right on the x-axis. Boom. And you got your x-intercept, you got your line. All right, now I'm going to do number 12. Well, it's going to be a long video, but you're going through it any way you want. Estimate graphically. All right, so 2x equals 10. What's it mean to estimate our answer graphically? It means that all the equations that you're going to solve during the semester for our class, the intersection of two graphs. So there are two graphs here. One of them is y equals 2x, and the other is y equals 10. Y equals 2x. We'll pick an x. Pick 1. I think I'm at a height of 2. Pick 2. I think I'm at a height of 4. In other words, that's just the line y equals 2x. This is the line y equals 2x. Okay, well, where's 10? 10 is up here somewhere. All right, and height of 10, we want to know what x value. Well, there it is. What do you think it is? Well, I think it's 5. I think 2 times 5 is 10. All right, so we're going to try practicing the graph on the left side of the equation, the statement, and our second graph is what we're looking at over there. And you're right, it doesn't say y equals. You got to supply that. All right, so let's try the next one. Let me erase. Let's go to problem 13. All right, problem 13 is 2/3 x plus 6. Oh, that's on the left side of the equation. I wonder if we can graph that. There's a product here, right? And products, what's 9.3 times 8.77? I don't know. What's 9.3 times 0? 0. You always want to make your product 0. So that means if you put a 0 in there, you're getting a 6. And I get the feeling you've been drilled with that in your Algebra 1 class, so hopefully I'm not having to tell you anything you don't know. So this is 0, 6, and I know I'm going over at a ratio of 2 to 3. So this time let's go over 30 units and let's go up 20. All right, that's a 2 to 3 ratio. All right, let's connect those, rotator cuff. All right, so there's the left side of this equation. What's on the right side? So I should have given you the whole thing. Well, I'm over here. Yeah, I know where I am. Yes. United States, that's right. -6. All right, from our previous problem, I guess -6 is, right about there. Woo, y equals -6. This is a pretty good graph. I think it's fairly decent. So where are these going to intersect? I think we're over here somewhere. Intersection of these two graphs. And that tells me I have a significantly, I don't know how close I was to this. I'm going to say -20. I really don't know. This was 6 units. I mean, I could do a better job of thinking about this. 6 units. 6, 12, maybe -18. I'm not sure, but let's go find it. Let's go find it. I shouldn't have erased that, but I want to just do the work here. So I'll take 6 away. 2/3 x equals negative, 12, right? So I'm taking addition of 6, so I'm doing -6, -6. Now I'm going to multiply by 3. 2x equals, oh, I had a good guess. Woo, -36. I nailed it. -18. I'm real pleased with myself on that one. All right. 14. 14. Let's see what 14 is. If I'm keeping up with the right numbers. X plus 5 equals 3x minus 4. X plus 5 equals 3x minus 4. You're trying it, I hope. So let's take a graph here. X plus 5, that's a 1-to-1 ratio. So we'll call that 5 units. Over 1, up 1. There's our left graph. The left side of the equation has been graphed. Now I want to go down 4 units. This is 5, so 4 is probably here, a little bit smaller than that distance. It's a good skill to learn, and this is a 3-to-1 ratio. Horizontal change of 1, the x sides change by 1, these change by 3. Whoa, all right. Looks like my x is going to be right about there. So that's 5, 5, 10, 11, 12-ish. Somewhere around 11, 12-ish, I think these babies are gonna intersect at that x value. And that means if I put that x value into the equation, I'm gonna get it so that this side equals that side. So let's go after it. All right, so let's go after it. So what do we have? We have, let me check something out. 2x plus 7x, I think that's 9x. I think that's 9x. Let's check it with a number. Algebra means it works for all numbers, so let's put a 10 in there. 20 plus 70 equals 90. I guess that's a true statement. So addition of 7x is what on the other side? I hope you say subtraction of 7x. And it sure looks like that's still true. So I have a choice here. I can either move the addition of x to subtraction on that side or addition of this. Most of you are doing that. I'm not. I'm doing that. I'm taking an x away 3x because dividing by a positive, I've got more reps in my life with that. I'm going to make fewer careless errors. And subtraction of 4 becomes addition of 4, and I don't like my choice anymore. I feel like my graph was not that good now. I can already see that my guess was a bad one, but it is a positive number, 4.5. It is positive, and it's on the right side, so I don't think it's wrong. Well, let's check it out. Let's do 9/2 just for the fraction practice. And let's do 9/2 over here. All right, let's do it out. All right, so what do we have here? We have 9/2 plus 10/2. Over here, we have 27/2 minus 8/2. And if you look at that, I think you'll see that that is 19/10. And that is 19/10. Okay, which is a height of 2. Oh, no. Oh, excuse me. That's a height of what? 9.5. Oh, okay. For a minute there, a little misfiring of the brain. All right, so now we're going to do 15. Problem 15. Doing them all for you. Minus 2/5 x. This one will take a little explanation. Minus 2/5 x minus 4 equals 4x over 3. I'm doing that intentionally, so you know either way it can be written. 4/3, where the heck am I? Minus 1. All right, so there's some things that you need to know. Let's look at the numbers as small as possible. If I multiply these by 10, I get 10 plus 20 equals 30. So I guess if I multiply by something, right, to each term, I'm still going to be equal. Okay, we've proven that. Let's make this a fraction. Let's make the number 1 4 over 4, and let's make the number 2 6 over 3. So now the question is, what number do I want to pick? I hope you say 12. And I hope you know that you can divide 4 into 12. We're trying to learn how to see it that way. 4 goes into 12, 3, and 3 times 4 is 12. 3 goes into 12, 4 times. And 12 times 3, I forgot to multiply by 6, excuse me. 3 goes into 12, 4, and 4 times 6 is 24. And 12 times 3 is 36. Boy, multiplying by 12 got rid of those fractions, and then it's an easier thing to look at. So we have a 5 and a 3. I hope your brain said, let's multiply by 15. 5 goes into 15, 3 times negative 2 is minus 6x. 15 times negative 4, 40 and 20, right? 4 times 15, I hope you're learning 4 times 10 and 4 times 5, right? We'll practice there. Okay, so that's 60. 3 goes into 15 5 times. 5 times 4x is 20x. And 15 minus 5 is minus 15. And we want to do it graphically too. So we'll check it graphically up here. Then I think I'll stop at 15. That's half of the problems because I am starting to get careless. I need my coffee. So we'll do it in parts. All right, so I'm going to bring the minus 6x to this side. I'm going to bring the minus 15 to this side. Okay, and it looks like I have minus 45 26, which is near negative 2. So let's graph it up here. Let's do a quick graph and see if our lines seem to intersect near negative 2. And I'm just going to do a really quick sketch. There's minus 4 down 2 over 5. Boom, that's that line on the left. That's the left line. This one's increasing. I'm starting at negative 1, so that's there. Over 3 up 4, over 3 up 4. Boom. Does that number look like it's near negative 2 for an x value? Sure does to me. So I guess that's right. All right, so that's 15 problems. And I am getting a little tired, so I'll come back to it when I get a little more oomph. Yeah, I'm an old man. All right. Geez, I didn't even button my shirt today. That tells you something. No, I did. Okay, good. So then we'll do the next 15. I think there's 31 problems, and again, refer to these. At least it's an explanation, and you're going to be doing these problems the whole semester. All right, see you in class on Monday.